In this spooky video, we're going to find the equation of a tangent line. In order to do that, we're going to understand what a tangent line is. We're going to use an equation to find the derivative, assuming that there is a limit. And then we're going to use another equation to actually find the tangent line. So, learning experience-wise, we're going to talk about what even is a tangent line. We're going to look at a couple of important equations that we're going to use. We're going to do an example problem, and then there'll be a you-do problem, and then some suggested practice problems at the end. So what is a tangent line? The official definition for a tangent line says, a straight line is tangent to a given curve f of x at a point x naught on the curve if the line passes through the point x naught, comma, f of x naught on the curve, and has a slope of f prime of x naught, where f prime of x is the derivative of f of x. This line is called the tangent line, or sometimes simply called a tangent. In more straightforward words, it's a line that goes through a point, and that matches the slope of that part of the curve. Wherever the point is, it has a slope, it will match that slope. So here's an example image of what that would look like. You have this curve over here. You have a point P, and right at that point, the slope is represented by this red line. That is your tangent line. So there are a couple of equations that we're going to need. Make sure you write both of these down. The first equation we're going to call equation 1. That is how to find a derivative when a limit exists. We have the equation f prime of a is equal to the limit of f of x minus f of a over x minus a when x approaches a. The second equation that we need is the equation of a tangent line in point-slope form. You're probably familiar with point-slope form if you've done any graphing. This is just a slightly modified version of it. We have y minus f of a is equal to f prime of a times x minus a. So we're going to need to do some distributive property there. There is another equation you might use. We're not going to use it for this video, but it's a different version of that first equation. You can look it up if you need to, but for what we're doing today, you should be able to just use that. So let's jump into an example. We need to find an equation of the tangent line to the equation f of x is equal to x squared. We're going to say that this happens when x is equal to 5. So the first thing that we're going to need is we're going to need to use that first equation, which we'll write down, and it's always a good idea to start by writing down any equations you're going to need. If you remember from the previous slide, we had f of a, or f prime of a is equal to the limit as x approaches a of f of x minus f of a, and all of that is over x minus a. So we're going to need to use this, and we're going to start filling in some of our things. That's basically the next step. So let's change color slightly to show that's another step. We're going to say that we have the f prime of 5. Since our x value is going to be 5, our a value essentially is going to be 5. We're going to replace that with that. We're still going to use the limit as x approaches a, which again in this case is 5. F of x just stays what we had earlier, so it's just going to be x squared. We're going to subtract, and I'm going to put parentheses around this because otherwise I'm going to forget that there's a subtraction sign there. We're going to say we have 5 squared. We're just taking our f of x equation here and substituting in a 5. All of this is over x minus a, which is 5, so we have x minus 5. That's our first step, just setting up the problem. Nothing too bad. Let's simplify this a little bit. I find that you don't need to write everything again, but let's write the important parts that are going to potentially change so that they're fresh. We have x squared minus 25, since 5 squared is 25, over x minus 5. We can simplify this a little bit by factoring our x squared minus 25. Again, we have the limit of x approaching 5. Since our x squared is both positive, we can assume most of the time that our x's here are probably going to be positive. One of them is going to be positive, one of them is going to be negative, since we don't have any x terms, any terms to the first power. And I know that to get 25, we'd have to multiply 5 and 5, or negative 5 and positive 5, since it's negative 25, so let's put a negative 5 and a positive 5 here. Our denominator looks exactly the same. We still have x minus 5. And now we can use the giant 1 method, if you're familiar with that. If you're not, it's probably better known as just canceling it out. I'm going to draw a giant 1, though, to show that that did, in fact, cancel out. So, we now are left with a slightly simpler equation. We're going to say that the limit as x approaches 5 is just going to be x plus 5. So at this point we can take the limit. And all we really need to do is we need to replace our x with a 5. So we have 5 plus 5, which is of course equal to 10. So f prime of 5 is going to be 10. Now what f prime really is, it's telling our slope for our tangent line. So our slope for the tangent line is just going to be 10. It's going to, in other words, if you were to plot it, it would go up 10 over 1. Nothing too bad. Now, we need to use our second equation now. We'll write this over here so that we have it fresh. Our second equation was the point-slope form for a tangent line. And if you remember, if you wrote that down, it should just be y minus f of a is equal to f prime of a times x minus a. Now the nice thing is that we already know quite a few things that we're going to need to fill in here. We already found what f of a is. We just found what f prime of a is, and we already know what a is. So we just need to substitute some things in. We still have our y, but we know that f of a is going to be 5 squared. We found that over here, which means we can just say that this is 25. So y minus 25 is equal to f prime of a. That comes from here. So we're going to say this is 10. We have x minus a, which was 5. So we just need to do that. Next, let's do our distributive property. We'll give this 10 to both of these terms. So we have y minus 25 is equal to 10x minus 50. We have to use our properties of equality. We add 25 to both sides. That'll get rid of the 25, or the minus 25, the negative 25 on our left side. We have 10x, negative 50 plus 25 is going to be negative 25. And that's all we need to do. So this is going to be our tangent line for f of x is equal to x squared at 5. If we just sketch this out real quick, f of x looks something like that. If we say that 5 is about here, our line, this would be 25, and it's going to be going up roughly like that. It's not a perfect drawing, but if you look closely, if you look very closely at it... Okay, so this u-do is the same thing as last time. We're going to use the equation f of x is equal to 2x squared plus 10 x at a is equal to 3, so it's a little bit more complex. But if you follow the same steps from the mini lesson, from the example, you should be totally fine. Pause the video now, give it a try. Good luck. Let's end this video by giving you 2 suggested practice problems. Again, these work exactly the same way. You have f of x is equal to 3x squared plus 2 at a is equal to 2, and g of x is equal to 4 minus x squared at a is equal to -1. Give those a try. Good luck.